Hi madam, my name is Modhan and I am from class DWM2A. My matrix number is 24-22F2003. Today my group was present about topic differentiation. Thank you.
Hello everyone, and my name is Tai Chiwei. I'm from class DAM2A, and my matrix number is 24 DAM 22F 2012.
Hello, my name is Rishikeshan. So my registration number is 24DAM22F2009. So we will be explaining about differentiation. So we will be explaining how differentiation will work on real world problems, and we will also cover the basics, advanced technique, and common mistake and more.
Now I want to explain about the definition of differentiation and application and importance in engineering. Firstly is definition. Differentiation is a mathematical process used to determine the rate at which one variable changes with respect to another. And secondly is important in engineering. In engineering, differentiation is crucial for understanding how things change over time and predicting future behaviors. And last one is application. Differentiation is used extensively in engineering to model change in fluid flow, heat transfer, and other physical systems. There are three types of basic differentiation rule that madam teaches. First one is power rule, second is product rule, third one is quotient rule. Product rule is used for differentiation function with constant, basic raised to variable exponent, and second is product rule used for differentiating the product of two or more function, and last one is quotient rule. Quotient rule is used for differentiating the quotient of two or more function. Now I want to explain about the application in differentiation in engineering. First one is optimization problems. Differentiation can be used to find minimum or maximum values of a function, which is useful for optimizing designs and processes. Second is rate of change. Differentiation can be used to model rate of change of a system over time, which is useful for understanding how system is involved. Lastly is tangent lines and linear approximation. Differentiation can be used to find a slope of a curve at a specific point, which is useful for approximating the value of a function near that point.
So these are advanced differentiation techniques. So there are three. One is chain rule, one is implicit differentiation, one is higher order derivative. Chain rule is used for differentiating functions that are composed of other functions. Implicit differentiation is used for finding the derivative of implicit function. And finally, higher order derivative is used for finding the second or higher derivative of a function.
For the example is that Max is an F1 engineer based on finity regulation. The fuel pump rate is 0.8 liters per second, and the fuel tank is a cube shape that can hold up to 113.5 liters. So he needs to estimate how long can the engine run. For this example of question, as you can see that we are going to use the rate of change. So for the techniques that we're going to do the rate of change is you need to define two equations for this. We just only need to define one because the other one is already given for you, like this one, the 0.8 liters per second. So we just direct copy out the information that we get, like the dl per dt equals to 0.8. This is in mathematically to define the 0.8 liters per second. And the second equation is that you can see here is cube, right? So you can just direct put the cube formula into it. So v equals to L cube. So the next thing that we need to find is dv per dt. So and the last information that we can get is v, the volume for the fuel tank, is equals to 113.5. Now we are going to find the dy per dx is equals to what? So as you can see here, if we separate out into two fraction. As you can see here, we can empty out the denominator and numerator to fill it out, because if we combine it, it's because that we can just cancel these two out if these two is the same. Now, the first thing that you can find is to find a similar thing from here to here. As you can see here, you can find dt and dt, right? And the dt is there's a value for it, so we just put a dl into it, and if here is dl, and the denominator will also be dl. Now we can get the dv per dt is equal to dv per dl times dl per dt. So because we already have the value for it, we just sub into it all. Now the next thing that we need to do is to find the dv per dl. So we just directly put in the formula for it. So if we definite the formula, we can get the dv per dl is equal to 3l squared. So the next step is just sub this thing into the equation. So we can get 3l squared times 0.8. Now the last thing that we need to find is the value for l. As you can see here, we didn't know that v is equal to 113.5 is equals to l cubed, right? So we just cube root the 113.5, then we can get the 4.8417. After that, we get this value, we can just put into the equation to find the dv and dt, dv per dt. Thank you. And here's all from me. I'm going to pass my teammates Rishi.
So these are some of the common differentiation mistakes and how to avoid them. The first one would be misapplying the rules. We should be careful to apply the correct rule to each function and follow the steps carefully. The second one would be forgetting to simplify or evaluate. Always simplify your answer as much as possible, and don't forget to evaluate it at the required point. So finally, the conclusion of differentiation. Differentiation can help in the introduction of the new concept in mathematics and make things easier to measure or investigate and help in new discovery. Differentiation is used in estimating the maximum and minimum in a matter. We need to know the basic rule in differentiation for real daily life.
Thank you.